Hello class, we are going to talk about moving the monster. So this is a great introduction activity for transformations. And transformations are anywhere from translation, where you're sliding something over, to rotation, where you're rotating something. But pretty much with linear transformations, we're pretty much going to deal with translations, which means sliding, whether that be horizontally or vertically. So the intro to this video is where we're going to be given the graph of f. And so what we're doing with this monster is we're going to plot every single point that's on the monster. So let's start with our first point. So we have -3. And when x is -3, our y is -1. And so on and so forth. Remember, another name for f of x is y. And so we're doing it for each point. So our next one is -2 and 2. Then we do the same thing in the middle. We have -1 and 1. Then we have 0, 3. Okay, which is our y-intercept. Then we have the other side, which is 1, 1. Then we have 2, 2. And then we have 3, 0. Okay, so those are the points on our graph. Then we'll put it in function notation. So that means when f of -3, okay, we get a -1. So now we're just using function notation to plot these points. So if f of -2 gives us 2, and so on and so forth. So there is our function notation based on the table. So then we have to complete the tables and sketch graphs of each. Now I won't do every single problem with you. There will be ones that you will have to do on your own. So I will do a few and then you will do a few. So for our first example, we have g of x equals f parentheses x plus 2. So there's something going on here. And so when we have x is -5, that's where we're going to plug our values in. So if x is -5, that means we plug in f of -5 plus 2. Okay, and with that we get f of -3. Okay, so all we did was plug in -5 where x was, plus 2, we do get f of -3. And so then we will refer back to our other table. So f of -3 pops out a -1. Okay, so then we'll do the same thing with f of -4. So f of -4 plus 2 gives us f of -2. And then we refer back to our function notation. F of -2 gives us 2. Then we do the same thing, so on and so forth. We get -3 plus 2 equal to f of -1, and f of -1 is 1. And then same with -2, so I have f of -2 plus 2 equal to f of 0. So now f of 0 is 3. So we're going to continue on forward. So f of plugging in x, which is -1, plus 2, end up with f of 1, and f of 1 is 1. Then we have f of 0 plus 2, which gives us f of 2, and f of 2 is 2. Then we have f of 1 plus 2, which gives us f of 3, and f of 3 is 0. So each time you get your output, or you get your input, you're going to figure out what your new output is. So note that these are your new x and y. So now I have new coordinate points. So then I can plot the point -5, -1, -4, 2, -3, 1, -2, 3, -1, 1, then 0, 2, and then 1, 0. So these will be the new spots on my monster. So let's plot those points. So we have -5, -1. Okay, and then we went to -4, 2. Then we have -3, 1. Then we have -2, up 3, 1, 2, 3. Okay, then we have -1, 1. And we have 0, 2. Then we have 1, 0. So there are our points, and we're going to connect those dots together. So now notice what happened from our original monster and when we moved it. So the graph is translated. So when we talk about translation, you see the SL means, the SL stands for like slide. So it means it slid over. So when we're describing the transformation, we say that the graph of f of x, because that's the original, okay, is translated to the left. So translated over to the left 2 units. Okay, so translate over to the left 2 units. Notice how if you went +2, you go to the right, but you went to negative, so you read opposite of, so you went to the left 2 units. So now you're going to do the same similar thing with example 2. So we have g of x equals f, and then we have f parentheses x minus 2. So the same thing here, you will plug in -1 for x minus 2, and you get f of -3 and f of -3. So each way you're going to have to refer back to the original function notation. F of -3 is a -1. And so I'm going to give you a few minutes, and you will do number 2 on your own. Feel free to hit pause and write if need be, and I will move on to the next example. Okay, so now I'm on to example 3. Okay, so remember you need to finish out number 2 before you move on to example 3. So example 3 has something different. We have f of g of x is equal to f of x plus 2. And so we're still going to plug in our values. So f of -3 plus 2. And when we do f of -3, we know f of -3, based on what it says on the front page, is -1. And then we're going to add that to 2, and -1 plus 2 is 1. And so just note that each time that you're finding f of a number, you're going to refer back to that front page. Okay, so then we have f of -2. And then we're going to add 2. F of -2 is 2, and then we're going to add 2, so then I have 4 as my new output. So now I'm going to input f of -1 this time plus 2. And so just for one time, so if you're confused on where -1 and 2 went, f of -1 is, so I have f of -1 is 1. So I'm going to plug in a 1 and then add 2. And then I get 3. So now I have f of 0. So let's look at f of 0. So here, make this a little easier. So I have f of 0 is 3. So I'll take 3 plus 2, and I get 5. Okay, 3 plus 2 is 5. Now I have f of 1, and f of 1 is 1. And then I add 2, and I get 3. Same thing with f of 2 plus 2. We know f of 2 is 2, so I take 2 plus 2, and I get 4. And our last one is f of 3. I'm going to add 2 to that, and f of 3 is 0, and 0 plus 2 is 2. So So there completes our table using our function notation. So now I'm going to graph my new points. So my new input was -3, and my output now is 1. So remember, so new x and y here. So now we have new points. So I have -2, 4 is a new point, -1, 3, 0, 5, 1, 3, 2, 4, and 3, 2. So those are my new points. So now I'm going to plot those new points on my graph. So now I have -3. Okay, so I'm going to go over -3, and I go up 1. Then I have -2, 4. Then I have -1, 3. Then I have 0, 5. There's one part. And the next one is 1, 3. Then I have 2, 4. And then I have 3, 2. So let's notice what happened. What happened to each point? Well, from this point to the next point, it shifted. This point to the next point, it shifted. So everything shifted up 2 units. So we would say the graph of f of x is translated up 2 units. We added 2, so it's up 2 units. So then you're going to do the same thing similarly to number 4. So number 4 says g of x equals f of x minus 2. So you'll complete the table, and then you have to tell me or describe the transformation of what happened to the monster. And so take this time to pause and try to attempt number 4 on your own. Okay, now we're going to move on to number 5. So at this point you should have completed number 4, and you found what happened to the monster on its transformation. So on to number 5, we have g of x is equal to f of negative x. So something is happening on the inside, but I'm still going to take that x. So I have f of negative, and then we have -3. So minus -3, which gives us an f of positive 3. And if we were to refer back to our chart, f of 3 or -3, or f of 3 is 0. So now we have f of 3 is 0. Okay, so we're going to keep continuing on with this. So I have f of -2, which gives us a positive 2, and f of 2 is 2. Okay, so we're going to continue on with -1. So then we have f of minus a -1, which gives us f of a positive 1, and f of positive 1 is 1. So then we'll do f of -0, which is no such thing as a -0, so it's just f of 0, and f of 0 gives me 3. So now we're on to our positive numbers. So then we have f of a -1 this time. Because it's not double negatives, we have single negatives. So f of -1 is just f of -1, and f of -1 is 1. So then we have f of, if you're trying to notice this, minus positive 2, which gives us f of a -2, and f of -2 is 2. Then we have f of -3, so f of -3 gives us -1. So there completes our table. So now we have our new input and output, which is -3, 0, -2, 2, negative 1, 1, 0, 3. We have 1, 1, 2, 2, and 3, negative 1. So let's plot our new points. We have negative 3, and we have 0. Then we have negative 2, 2. We have negative 1, 1. Then we have 0, 3. Then we have 1, 1. Negative 2, 2. Then we have 3, negative 1. Okay, so there. Alright, so there is our monster, and I'm going to shade what we have. So it's hard to tell, but if you notice, something happened here. And actually, our line actually reflected. And so when we have something with reflection, think of the FL meaning to flip. So it means it went like this. So it, like the flip of my hand, I went from the front side to the back. So describing this transformation is the graph of f of x is reflected across, and normally we have reflection, we're reflecting across something, and our middle symmetry point is the x-axis. So we reflected across the x-axis. Actually, across the y-axis. We reflected across the y-axis. Oh, I'm sorry. We reflected across the x-axis. I apologize. The x-axis. And it's hard to tell, but because we flipped from our negative and positive numbers on the x-axis. So that's how it's reflected across the x-axis. Okay, so this time you're going to see what happens when you do number 6. So this one's a little different because I have a negative on the outside. So then I would have negative f of negative 3. And so that means f of negative 3 is already a negative 1. And negative times negative is a positive. So same with 2. So f of f of negative 2. We already know f of negative 2 is 2, but we need to make it positive, so we end up with negative 2. So then you'll do the same thing for this one as we did for the other, but there's going to be some sort of different reflection happening here. So take the time to hit pause and complete question number 6. Okay, now we're doing number 7. At this point, you would have completed number 6. And so now we're going to move on to number 7. So number 7, we have g of x is equal to f parentheses 1/2 of x. And so we're still going to plug in our inputs with f of negative 1/2, and our x is negative 6. And so that leaves us with negative 6 times 1/2 is a negative 3. So f of negative 3 is negative 1. Okay, so remember you're using that shortcut. So then we do the same thing with negative 4. So 1/2 and multiplied by negative 4. So we have f of negative 2, and f of negative 2 is 2. So on with negative 2. So 1/2 of negative 2 gives us a positive or a negative 1, and f of negative 1 is a positive 1. So remember, we're kind of rotating back and forth between our first original function notation. So now f of 1/2 of 0, anything times 0 is 0, so I have f of 0, and f of 0 here is 3. Then 2, we have f of 1/2 times 2 gives us positive f of 1, and f of 1 is 1. So 1/2 times 4 gives us a positive f of 2, and f of 2 is 2. Number 6, or f of 6, we get f of a positive 3 this time, and f of positive 3 is 0. So now I have my new input and output with new points. So x is negative 6, and y is now negative 1. I have 0, 3, 2, 1, 4, 2, and 6, 0. So now I'm going to plot my new points on my graph. So I have negative 6, negative 1, negative 4, up 2, over here, negative 6, negative 1 is there. So pardon that part. Alright, continue on. We all make mistakes. It's just a matter of how you're going to go about fixing them. So then we have negative 4, 2, and then we have negative 2, so 1, 2, and up 1. Then we have 0, 3. Then we have 2, 1. So 2, 1 is here. And then we have 4, 1, 2, 3, 4, 2. Then we have 6, 0. So something happened here. Okay, so what happened to this line? So the graph actually got bigger. It stretched out. So it's like we took a slinky and we were to stretch it on out. So the graph of f of x is stretched, and it's stretched a certain way. So we didn't stretch it long ways, you stretched it this way, and going left to right is horizontally. So it is stretched horizontally by a factor of 2. And so we're using the factor of 2 because we're reading the reciprocal of 1/2, okay? So we have something that's stretched horizontally by a factor of 2 because the reciprocal of 1 over 2 is 2 over 1. So that's why we have a stretched horizontal factor by 2. So then we'll see what happens when you plug in 8. So in this case, so very similar to the top, we now have decimals here. And so I'm going to still take f of 2 and I'm going to plug in my negative 1.5. And I were to type this in, I do get f of negative 3, which gives us negative 1 as our output when we refer back to our table. And so let's see what happens when you come up with these and what happens to our monster after we plug in all of our values. So this is the moment where I'll give you time to pause so you can complete number 8 as shown below and describe its transformation, whether it's stretched horizontally or you can say compressed. Remember, we're also talking about, we said the factor of 2 because it is the reciprocal of 1/2. So be very careful on how you're describing your transformation. Okay, at this point, you would have completed number 8 and told me what the transformation was. And so this time I'm going to do something a little different. I'm going to do number 10 and you will do number 9 on your own. So number 9 you'll do on your own. I'm going to do number 10 with you. So number 10, says g of x is equal to 2 times f of x. So I have 2 times f of negative 3. Okay, so I'm multiplying those together, and we know f of negative 3 is 2, or is negative 1. So I have 2 times f of negative 3, which is 1. And so I get negative 1. So I get negative 2 is my output. So let's try this again. So I have 2. I'm going to plug in my x value into f of x. So that means f of negative 2, so that's where I plugged them in. So then I have 2 times whatever f of negative 2 is. And f of negative 2 is a positive 2, and 2 times 2 gives me 4. So then I'll do the same thing. So I have 2 times f of negative 1. So I have 2, but we know that f of negative 1 is 1. So I'm going to plug in a 1 here. And so 2 times 1 is 2. Now I have 2 times f of 0. And this time with 2, f of 0 is 3. And 2 times 3 is 6. Then I have 2 times f of 1. So I have 2 times, and f of 1 is 1. And so I get 2. Then I have 2 times f of 2. And 2 times f of 2 is same as 2 times 2, and I get 4. Then I have 2 times f of 3, and f of 3 is 0, and 2 times 0 is 0. So now I have my new input and output, and I can create new points this way. So x is negative 3, so y, or g of x, is negative 2. Then I have negative 2 and 4, negative 1, 2, 0, 6, and I have 1, 2, and I have 2, 4, and 3, 0. So we're going to go ahead and plot those points on our graph. So I have negative 3, so 1, 2, 3, and I go down 2. Then I have negative 2, up 4, 1, 2, 3, 4. Our next point is negative 1, 2. Then I have 0, 6. Then I have 1, 2. So I'm going over 1 and I go up 2. Okay, then I have 2, 4. So I go 2 and I go up 4. And our last point is 3, 0. So something happened here. So we had a stretch. So something happened. Not only did we stretch it, we can't stretch it horizontally, but we did stretch it vertically. So the graph of f of x is stretched. So just like a slinky, it is stretched, but instead of being stretched on the x-axis, it's being stretched by the y-axis. So it's stretched vertically by a factor of 2. So notice the 2 in front, that tells you on the outside, unlike the horizontal one, we're taking a face value from the front side, and you can also tell that it's shift. Okay, so the scale factor here is going to be the same number for vertically stretched or vertically compressed. So when you do number 9 on your own, you might have it stretched vertically or horizontally, or it might be compressed. And it might be a factor of not 2, but it might be a factor of something else. So if we were to do number 9, so let's say we had 1/2 f of negative 3, but we know f of negative 3 is negative 1, and negative 1 times half, it's still just half, so it would be negative 0.5. Okay, just know you might be graphing half marks here. So if we do the same thing for the second, we have 1/2 f of -2, but f of -2 is 2, and 1/2 times 2 is just 1. So you might have some halves, you might have some wholes, but see what happens after you graph and what happens to your transformation. Does it get stretched or does it get compressed? And so you'll do number 9 on your own, and that will be the last one that you'll do out of this Move the Monster packet. Again, this is also going to help you with number 12, or not number 12, your homework A12, and number 5 when we talk about transformations. So hopefully this is helpful, and that concludes notes for today. Please make sure this packet is completed and you may turn it in before the bell rings. Okay, if you are completed with that, note that the end of the 6 weeks is Friday, and so I will require extra credit, and then there's always tutoring Thursdays with me after school. Thank you so much.